Hey guys, it's me, Jose. Basically, the disease I chose was human African trypanosomiasis, or HAT. It's basically a parasitic disease. It's also known as the African sleeping sickness. Um, First thing I'd like to point out is that I'm using a card just to help me with some of the harder words. I'm not actually using it to read off of the actual information inside my project. Anyways, as far as the history goes, basically it was first discovered by the Western world in the 18th century by a ton of European ship doctors and medical officers. So basically, they were all stationed on the Atlantic coast of Africa, and essentially they were able to observe the disease and kind of document it for the first time since they were stationed there. Moving on to the symptoms and diagnosis. Basically, there are two different types, or sorry, not types. Stages to this disease. The first stage includes physical symptoms. That will include fever, joint pain, swelling of the lymph nodes, and so on and so forth. The second stage would be more neurological. That stage would include psychiatric disorders, coma, seizure, and unfortunately death. Basically, you can diagnose someone for it by basically first, of course, screening someone to see if they match up with the symptoms. Then after that, you can use a blood smear to see just to have a quick look at their blood sample, and to really get down dirty and actually like diagnose them like for real though, you can take a blood sample and analyze it for antibodies against the parasite. Because if there are antibodies that are made by the body against parasites, it means the parasite is present there, and that means that they obviously do have the illness. Also, there is another test called the cerebral spinal fluid test, where basically you take some spinal fluid and you examine if there are any parasites there. So if there are, then that means that it's in phase two, because the switch from the stage one, stage two is the crossing of the parasite through the blood brain barrier, actually. Um, Contraction. Basically, there are two separate ways in which you can get this disease. The first one would be getting bitten by the tsetse fly, which I kind of depicted here. Um, or other type of blood-sucking insects like leeches, for instance, who have the parasite, who are like carriers for it. So basically, what would happen is that their saliva would mix in with our blood once they bit us, and we'd end up with a parasite in our system. On the other hand, there's also this other option, which you can come in contact with body fluids belonging to mammalian hosts for this disease. The problem, however, is that when you're looking at these cases, you're gonna learn that surprisingly enough, they're very very rare. In which someone's going to get infected through a blood transfusion or by because their mother gave birth to them as they were sick with this disease. Usually, there's not really much placental fluid or blood transmission issues that we run across in these situations. Moving on to prognosis. So basically, it's very straightforward. If you get the treatment, you will survive. If you don't, then you will die. Um, Essentially, there are two different types of the disease itself. One is a Western sub-Saharan African strain called TB. I want to say, hmm, Gabensi. Gambensi. Sorry about that. Gambensi. So basically, it's responsible for 98% of the cases that we observe. It's actually a milder, even though it's more chronic, since you can end up with it for years and years. However, it's actually much more preferable to its brother, I guess you could say, the Eastern Sub-Saharan illness, in which that one covers only 2% of the cases, but is much deadlier, much more severe. It can kill in a matter of weeks or even months. So basically, that's just talking about the actual prognosis. There's really not many permanent effects that you get from this, because the treatment's so effective at actually killing the parasites that you won't really be left with much in your system. And the only thing is you won't get actually any immunity from whatever treatment you get. So it's basically like getting infected from like the first time all over again. Treatment. There is no actual cure for this disease. However, there are four main treatments, but unfortunately, they all have their disadvantages. The first one, or actually the first two, sorry, are I want to say primidine, and also ceramidine. Hold on. Let me just make sure I'm saying that right. Pentamidine and ceramine. So basically, these two are great against stage 1 of the virus, but the problem is that they really don't do much against stage 2. Moving on, there's mersopirol, and mersopirol is great for stage 2 because it crosses the blood-brain barrier. But the problem, however, is that it's highly toxic and it's highly painful for anyone who actually receives it. Patients have even said it kind of feels like fire in the veins. Therefore, it obviously has that drawback. And also the fourth and final one here on this list would be a fluorinthine. And a fluorinthine is unfortunately one of the more expensive and harder to administer drugs. So that's why it's not a very viable option either. Let's move on to prevention. The reason I put the star here is because I'm going to mention my article here. But first, I'd like to go into what you can do to protect yourself. So basically, insect repellents won't really work. What we can do is wear like dull protective clothing and also bed netting. So say I were in the Democratic Republic of Congo, I was spending the night there. I want a bed net all over the place, and I also probably end up wearing like dull, like dark brown or something like that, long sleeves in order to make sure that I'd have lesser chance of actually getting bitten by the tsetse fly. Um, let's see here. There is no vaccine like whatsoever for this disease, but what you can do is that you can actually take a shot of pentamidine, and it'll have sort of like vaccination effects, and that it'll kind of give you a leg up on the competition, so to speak. Because if you get it before you're infected, then you have better chance of survival. Uh, the actual article I chose was from Doctor. It's from a Dr. Tyradis. He was a researcher, actually. Basically, he used mathematical formulas, and he was able to determine a specific number of certain traps that can be used in order to take down over 90% of a tsetse fly population within a 500 square mile radius, or sorry, a 500 square mile population density of people. So basically, it'd be really beneficial because it'd be again another prevention technique, except it'd be a lot more efficient because instead of investing so much money in treatment and differentiation and telling who has and who has not the virus, these kind of like the stories at its core, like because there won't be any carriers to really give you the virus in the first place, which might actually be more intelligent because it'll be hard to admit to give everyone the same medicine. They might not be able to afford it. Might be hard to reach them. So